Hi, welcome back to our Honors Geometry series. On this video, we're going to talk about how to identify the corresponding parts of your similar triangles and how to use those corresponding parts to set up proportions and solve for missing sides. So first thing we should do is take a practice run at a nice separate triangle problem. Let's take a look at example 3a. I'd like you to try this one on your own. Pause the video. When you're done, unpause and check your work. Alright, so you should have finished by now. If not, pause the video and try it on your own. So I can see that 10 over 20, 10 and 20 correspond, equals 13 over x. X should be 26. How did I get that without any math? Well, 10 is half of 20, 13 is half of 26. But in order to help us do these problems on a more challenging level, we need to identify what thought processes did we go through to help us identify the corresponding parts. Well, 10 and 20 are both adjacent to a right angle. And 13 is the included side between two angles. And x is the included side between those two marked angles. So you need to use the angles to tell you where your corresponding sides are. For example, on B, I've got two right angles and I've got two congruent angles there. If I look across from my congruent angle in this smaller triangle, there's one. That would be x plus 6. That's the side opposite the angle marked one time. In my other triangle, in its similar triangle, the side across from the angle marked one time is WU. But I don't know what WU is. Now, luckily, I know what the Pythagorean theorem is, and I know how to use it to solve problems. But the problem there is, even if you were to use any other two triangle pairs to solve this, you would still need to do the Pythagorean theorem. So we have our legs of x and 32. Our hypotenuse was 40. So if you set up your Pythagorean theorem, x squared plus 32 squared equals 40 squared. And you'll see that the triangle here is just a fancier 3, 4, 5 right triangle. And that's 24. So 8 times 3, 8 times 4, 8 times 5. Okay, now that that's out of the way, let me move this. Move that up. So we said across from the single mark there was x plus 6. Across from the single mark over here is 24. Now let's try some other congruent angles. We only have one other angle that's marked as congruent, these right angles. So I could do 3x minus 6, and across from the right angle here is 40. I could do that. Now, of course, you could do, because of the third angle's theorem, we know that these are congruent as well. You could do 24 and 32, and that should work. I'm just going to go with the ones that are already marked. It's a little bit easier to see what angles to use when they're already marked for you. So now if I cross multiply, I will get 40x plus, and then 40 times 6, make sure that you distribute to both parts, is 240, equals 72x minus, and then again, you've got to do your 24 times 6, which is 144. It's 120 plus 24, 144. So then when you simplify, you get 32x equals 384. or x is 12. All right, I want you to try C on your own, and then we can try D together. So again, pause the video, try it on your own, unpause when you're ready to check your work. All right, this one's not too bad. There's one trick though. So I've got these side angle side similar triangles. And I can see that 20 appears to match up with, but I'm not sure yet, 2x plus 1. And 12 appears to match up with 2x minus 1. Now, that's what it looks like. But my question for you is, how can we be sure? How can I know that those match up? Well, 20 is the longer side. How do I know that this is the longer side and this is the shorter side? How do I know that 2x plus 1 is longer than 2x minus 1? Well, anytime you add a positive integer, you're getting a larger value. Anytime you subtract a positive integer, you're going to get a smaller value. So this must be necessarily larger than 2x minus 1. And then when you cross multiply, 40x minus 20 equals 24x plus 12. And you would get 16x equals 32, or x equals 2. Now D is probably the most difficult one. On D, you've got 3 triangles to worry about. The ones that we're really going to focus on are, because this angle here represents the entire angle H, it is opposite of this full side of GJ. So it looks like we're going to work with the largest triangle, and then I see its corresponding part is here at D, HDG. So it looks like our 2 angles that we're going to be working with are this smallest angle and my whole entire triangle. Okay. So let's start with the marked angles. We'll start with this big angle here at H. Across from it is GJ, but I don't know what that whole measurement is, so I don't know if I can use that. Okay, that's unfortunate, but we can keep moving forward. We tried one, let's try the second one. So this marked angle has 2 markings in it, and in my smallest triangle, it is across from 2x plus 4. Okay. Now, in the largest triangle, we're going to have to zoom out just a bit. And I'll do my best to help you visualize this by covering up the middle of the triangle. Here's my large triangle. In this large triangle, what side is across from this same corresponding angle that has 2 angle markings? Well, the side across from that is 10. So 10 is across from that angle in the largest triangle. And in the smallest triangle, the angle that is across, or the side that is across from that same corresponding angle, is 2x plus 4. So those two go together. So we tried the single marking. That didn't work out for us. We tried the double marking. That did work. There's only one other angle pair to try, and it's the unmarked angles. It's this smaller angle here at H, GHD. So that's the last angle we haven't used in my smallest triangle. Across from that angle is 2x minus 2. I'd like you to see if you can identify what's across from the unmarked angle in the largest triangle? What is the corresponding side to 2x minus 2? So I'll give you a second to think about that one. What is the corresponding side that is across from the only unmarked angle in my large triangle? And that would have to be 7. This is unmarked. Across from that is 7. So now when we cross multiply, 14x plus 28 equals 20x minus 20. So you get 6x equals 48, or x equals 8. And then, of course, you can take these x values and substitute them back in to your expressions to solve for any missing side lengths. So that's how I would identify the corresponding parts in a set of similar triangles.